So, the Edwin A Link Lecture. Edwin A Link, or Ed Link as he's usually called, was the inventor of the Link trainer, better known as the blue box. And essentially that led to the entire field of flight simulation, which is why I'm here and why many other people in the room, I'm sure, are here. In his honour, in 2007, the Flight Simulation Group here at the Royal Aeronautical Society inaugurated the annual Edwin A Link named lecture. And that inaugural lecture, delivered in this same room, was given by Air Vice Marshal Jock Stirrup, and it was entitled On the Role of Simulation in the Defence Environment. Now, like many of the lectures that are given here as public lectures, you can listen to that online on the or as an Aero Society podcast. Just type Aero Society Ed Link, you'll find them. In his lecture, Jock bravely made a few predictions. So I thought it'd be very interesting to invite, as this year, as the speaker for the Ed Link, the first holder of the newly created post of RAF Chief Modelling and Simulation Officer, to share his views on how accurate Jock's predictions were, but more importantly on where we are today and where he thinks we should be going. Very pleased to say, Group Captain Ruari Henderson-Begg accepted the challenge and he'll be delivering the lecture. As the Chief Modelling and Simulation Officer, he is responsible for the development of the air component of UK modelling and simulation strategy for the Royal Air Force. Prior to this role, Ruari was an extensive user of full-flight mission simulators on the Tornado GR1 and GR4 as a navigator, and more recently, a provider of simulation capability, having spent 5 years delivering the RAF's Gladiator capability, which is the UK's first distributed synthetic collective training capability. From my discussions with Ruari, I know he has a very clear vision of where he thinks modelling and simulation capability should be going and where they need to be for the UK air domain. He's going to share some of that this evening. Ladies and gentlemen, please give a warm welcome to Group Captain Ruari Henderson-Begg.
Mr. Chairman, Society members, guests, thank you very much. It's an honour to be asked to give this iteration of the Ed Link Lecture, and I have to confess to a rather large dose of imposter syndrome tonight. We've had a lot of very high quality lectures today and presentations, and I hope to draw on some of those threads as we go through over the next 30 minutes or so. And what I would like to do is to share my thoughts on the importance of simulation to aviation by examining its use by the Royal Air Force since World War II through to the present, by analysing its strengths and weaknesses, and by considering how we might use simulation to deliver battle-winning capabilities in the future. Now, I've never been a very good poker player, so let me lay my cards on the table right at the beginning. I believe that the next conflict will be won before the first shot is fired, and that the side that wins it will be the side that makes best use of technology, including modelling and simulation. That might be a slightly bold assertion, so let me explain my thinking. But first, I think it would be useful to create some common ground by agreeing on some common definitions. Firstly, simulation. It's a word that everybody understands, but everybody understands it differently. So the simplest definition that I can find is this. A simulation is an imitation of a situation or a process. So therefore, everything we do in training is a simulation. It doesn't matter whether we're in a live aircraft fighting against live opponents with live weapons, in a full mission simulator, using an extended reality headset, a desktop trainer, or even gaming on an Xbox or PlayStation, and I can see quite a few gamers in the audience. Every time we do that, whatever we do, we're simulating doing something for real. Synthetics is another word we all think we understand, but again, I bet we struggle to come up with a common definition. NATO avoids that word for the very reason, and so I'll try to. But if I do use synthetics tonight, please assume that I'm using it in a broad term, to define the various simulation and simulator-based activities, such as training or research and development, that we undertake. Now, in the modern world, we tend to equate simulation with the use of high-powered computers, immersive synthetic environments, and increasingly, technology like extended reality. But not every simulation is like that, and many simulations are much cheaper and don't involve cutting-edge tech. Hopefully this will work. Sorry, that's a little bit blurred, but hopefully you can see it. As an example, my wife recently bought me a skydiving experience. Now, I'm not completely new to the sport. After nav flying in the mid-90s, when I was much younger and braver, I did a freefall course and I got up to 10 seconds of freefall, which I was pretty chuffed with. But each jump was a very short experience with a great chance that something could go wrong. Although I can assure you that being responsible for packing your own parachute very much focuses in mind. This time round, I didn't risk life and limb by jumping out of a perfectly serviceable aircraft. I spent 4 minutes with an instructor on top of a high-powered hairdryer, relearning how to fall gracefully. Now, I get that that's quite a banal example, but it does give us the opportunity to analyse some of the advantages that simulation offers us. Firstly, cost. Indoor skydiving may not be cheap, but it's certainly cheaper than live freefall. I've now got about 2 hours of tunnel time, and that's something I could never have afforded in the real world, but it's allowed me to make a lot of progress and get a lot more time and progress and fun for my money. In the aviation context, using simulators allows us to make best use of expensive live flying hours by reserving them for activities that we can't do in the sim, and we can't do everything in the sim. Secondly, safety. When I look back at my logbook, only 2 of my jumps were classified as good all the way, and on at least 2 others, I ended up on my back, which made for some interesting canopy deployments. While every skydiving company focuses on safety, accidents do happen, and falling from a great height generally only ends one way. If there's a problem in the tunnel, they turn the fan down. I drop to the net with only my pride dented. Simulators allow us to practice emergency procedures and make sure that we can respond to real-world situations quickly and effectively. And looking around the room, I'm fairly sure that most of us aviators have at least one emergency under our belt. And then finally, focus. The wind tunnel allows me to practice one thing as many times as I need to, with an instructor in the tunnel beside me and with a quick debrief after every attempt. That allows me to maximise the progress I make in each visit and my value for money. The same principle applies in a flight simulator. An event can be practiced and debriefed as many times as necessary without running out of fuel or of weapons. A military use of simulation has one further advantage, security. But I'll talk about that more later on. When I look back at development of the Link trainer, it seems to me that Ed Link was probably motivated by many of the same factors. Aviation was a new frontier, bringing existing technologies together in novel ways to allow mankind to conquer the air. Consequently, learning to fly was an expensive and a risky business, with your instructor's skill and teaching ability a key factor in your success and possibly even your survival. But because Ed Link was passionate about learning to fly, and because he had the relevant engineering background and the imagination to see how existing technologies could be used in novel applications, he was able to invent something new and something that fundamentally changed flying and flying training. However complex modern simulators are, they all come from that one blue box, and that's quite something to think about. World War II massively increased the Allies' need for trained aircrew to fly their fleets of fighters, bombers and reconnaissance aircraft. And that would have been nigh on impossible without access to simulators like the blue box. And so Ed Link's invention can be seen as a critical factor in enabling the air victories that enabled a successful outcome to the Second World War. Well, from our perspective, at least. As Air Marshal Robert Leckie, who was a Royal Naval Air Service and Royal Air Force pilot who ended his career as the Chief of Staff of the Royal Canadian Air Force, said, and I'll quote this from the paper, "The Luftwaffe met its Waterloo on all the training fields of the free world where there was battery of Link trainers." And yet, this battle-winning invention nearly failed. Link's company struggled during the Great Depression, and he was reduced to selling the Link trainer as a fairground ride. The invention didn't take off, if you'll pardon the pun, until the US Army Air Corps adopted it in 1934. But by the end of the Second World War, Link had produced over 10,000 blue boxes, and they were used in every flying training school in the Allied nations. If we fast forward to the modern day, both the military and civilian aviation sectors make extensive use of simulators. And while some aspects of our training differ markedly, there are areas like emergency handling that we all need to practice. From personal experience, the opportunity to practice emergency procedures until the immediate actions become instinctive has saved me from having to use an ejection seat on a number of occasions. But perhaps a more accessible example is immortalised in the film Sully, which shows how an experienced and capable pilot dealt with a catastrophic emergency against all the odds. But the film also showed us how simulators can lead us to learn false lessons and how they can omit real-world factors. I remember the courtroom scene when the lawyers attempting to prove that Sully's actions had caused the loss of the aircraft confessed that it had taken them 18 attempts to land the aircraft safely at one of the airports. And then only by removing the delays in reaction time that are a factor in our ability as humans to understand and react to real-world situations. Once these were reintroduced, it was impossible to land the aircraft safely, no matter how many times they tried. So my takeaway from this is that learning those instinctive actions, using a simulator to practice them until they become second nature, is absolutely important. But it must be accompanied by training in critical thinking and the experience to match those academic reactions to a real-world situation. We must beware of putting all of our faith in simulators and make sure that we conduct appropriate safety and assurance activities in the real world as well. Now, while we all need to be able to operate our aircraft safely and effectively, military aviators also need to be able to do this while operating their weapons, sensors, and deploying their tactics in a hostile environment where somebody is generally trying to kill you. And that's normally as part of a combined package operating across all 4 physical warfighting environments. That takes a very different set of skills to civilian flying and means that some military training simply can't be conducted in peacetime airspace or in a live environment. My journey into simulation began with the hand-eye coordination tests at RAF Biggin Hill that some of you may remember. Possibly not a very realistic simulation. In fact, definitely not a very realistic simulation, but much safer and more effective than putting candidates into a live aircraft. The Air Force's analysis of my flying skills was confirmed on the University Air Squadron. Having worked my way through the first solo syllabus, as navigators and engineers did at the time, the squadron boss finished my pre-solo check with the motivating words, "Well, you're as ready as you can ever be. You've got one circuit and one circuit only. Do not go around. Do not leave the visual circuit." Not the most encouraging pep talk, but probably a good example of pragmatic risk management and a very accurate assessment of my flying skills. In basic nav training, my primary simulators were cardboard cockpits for the Bulldog and Tucano, where I learnt the basic system startup and management checks. Once we got to the Domini, we graduated to our first proper simulator, a suite of navigation and mission systems set up in the same cramped configuration that we'd meet in the back of the aircraft, and where we practiced every sortie before flying it live. And even when I got to the Tornado GR1, the simulator was more of a systems trainer than what we would call a full mission simulator. While we had movement, there were no visuals, and so the sim was largely used for emergency handling and for learning and practicing weapons delivery and instrument flying procedures such as the low-level terrain following. By the time I left the service, the Tornado, and by the time the GR4 left service, the sims had pretty good visuals, and we could link 2 cockpits together, which greatly enhanced the usefulness of our synthetic training. And as an instructor on the Tornado GR4 operational conversion unit, there were regular occasions when we would progress students through the syllabus based on their performance in the simulator, especially when weather or aircraft availability were constraining their progress rather than a lack of ability on their part. But despite all of these improvements, our synthetic training still had one major drawback, and one that shows that technology is only part of the answer. Every time I talked to someone outside of my cockpit, an air traffic controller, my fighter escort, or a ground call sign, I wasn't talking to the real deal. I was talking to a sim instructor who was role-playing a capability or a role they may never have been competent or trained in. And I think we can all see how that limited the benefit that we got out of that synthetic training. At the same time, the RAF was experimenting with synthetic collective training by linking representative fast jet mission trainers to the AWACS's rear crew trainer and to the forward air controller equipment at the Air Battle Space Training Centre, RAF Waddington. The Defence Synthetic Air-Land Trainer, or DSALT, was focused very much on air-land integration. But what it did do was bring service personnel from all three services together in a common synthetic operating environment to train, in exactly the same way that they would subsequently operate in Iraq or Afghanistan. The additional benefit that came from these intense periods of collective training was the relationship building between operators who would soon be relying on each other in a real wartime operational environment. The RA's vision at the time, as set out by Air Marshal Stirrup in the first Ed Link lecture, was for a network of federated targeted fidelity mission trainers that would enable us to scale the DSALT approach up to an RAF-wide capability. Now, the mission training through distributed simulation initiative was unaffordable and so never actually entered service. Although, as we'll see, targeted fidelity systems increasingly form part of our collective training and our synthetic training capabilities. A modern example of this approach is the Virtual Test and Training Centre, a US capability where the US and its allies can come together to conduct high-end, high-fidelity warfighting in a very high-fidelity synthetic environment. If we look more widely across defence, in the late 2000s, it was obvious that we couldn't complete our entire operational training requirements simply using live activities. Therefore, certainly from an Air Force perspective, maintaining our effectiveness as a fighting force meant making more and better use of simulation, upgrading our training environment, our live training environment, but also expanding it to combine live and synthetic capabilities into a combined blended training system. And thus were born the Defence Operational Training Capability, DOTC Air, and the Air Support to Defence Operational Training ASDOT programs. Now, some of you will remember the ill-fated ASDOT program. We'll gloss over that, and I'll focus on DOTC Air for the time being. I came to the program as its scope was being defined before main gate. From the outset, it was seen by the sponsor, Air Commodore at the time Link Taylor, as an experiment that might fail, but that if successful, could provide the foundation for a defence-wide capability. Our initial aspirations were relatively modest, to provide a distributed synthetic training hub at Waddington and a White Force, and to integrate a small number of platform simulators from Typhoon, Lightning, the AWACS and Joint Fires. Other platform simulators from across air, maritime and land were expected to follow once we'd proven the initial capability and justified the expenditure. The key difference between DOTC A, very quickly renamed Gladiator as less of a mouthful, and the DSALT capability was that instead of bringing everybody together to operate from targeted fidelity mission trainers, people would stay on their main bases and use their high fidelity flight simulators. The principle was that the reduction in relationship building opportunities would be offset by the avoidance of any negative training caused by differences between the cockpits on the main base and the targeted fidelity trainers. A year and a half after entering service, Gladiator is delivering high-quality training to UK personnel. A number of platform integrations are complete or underway. We have well-established links to other distributed synthetic training locations in the US and in Europe, and we are accessing and delivering training on a national and an international level. Of course, the programme didn't survive first contact with the enemy. It never does. COVID delayed delivery, and integrating simulators delivered by individual OEMs using different components, data standards, architectures has proved more complicated than we hoped it might be. But overall, Gladiator has been a success, and this is shown by the Royal Navy's decision to use its architecture as the basis for its Spartan collective training capability. And we're also using the same architecture and many of the same components in the Rapid Capabilities Office as the basis for AIR's synthetic experimentation capability and to develop prototype mission trainers for a number of aircraft. This allows us to maximise the return on our investment and mitigates shortfalls in training capability and capacity, and moves us closer to delivery of that original mission training through distributed simulation concept. And finally, and most recently, innovative work by the Aerospace Warfare Centre and by the AirCap Next Generation Operational Training Team is beginning to knit the UK's live and synthetic training environments together. Last month saw Exercise Joint Warrior, which took concurrent live and synthetic activity and knitted it together as part of the culmination of the UK's Qualified Weapons Instructor course and a capstone multi-domain operation training event. Now, I think it's important to stress that I don't think simulators are the answer to everything. They're not a golden bullet, they're not a complete replacement for live flying. Simulators have strengths and weaknesses which mean they can never fully replace live activity, whether that be training, test and evaluation, or safety and assurance activity. But we can use them to complement, augment, and enhance that live activity. Whether we are military or civilian aviators, using simulators allows us to maximise the benefit of expensive live flying hours and make sure that each activity is carried out in the most appropriate environment, whether that be live, synthetic, or blended. And there are many compelling reasons for increasing our use of simulators. I'll focus on two. First, no surprise, surprise. I suspect that no one in the audience, unless you've lived in a cave for the last 4 years, has missed out on the war in Ukraine. And so you'll understand that the widespread use of air-breathing and space-based surveillance capabilities means that no part of the Earth escapes almost constant surveillance. Everything that happens on the ground, in the air, over networks in cyberspace is noticed, seen, and potentially recorded for subsequent analysis. That makes it very hard to surprise your enemy, although Ukraine's Kursk offensive shows this can still be done. So maintaining any operational edge means having offensive and defensive capabilities and tactics our adversaries don't know we possess, and for them to work the first time we use them. Simulators in synthetic environments allow us to develop, refine, and rehearse sovereign capabilities and tactics without risking their exposure, enhancing their operational effectiveness by maintaining that element of surprise. And this is especially important for 5th and 6th gen capabilities like Lightning. And details of our most advanced capabilities are very closely guarded for good reason. As a World War II poster said, careless talk costs lives. And so access to highly classified information is carefully limited. And this gives us a problem. While we can train small numbers of people at high classifications, a secret shared is a secret halved. So the more people you have, the rule of thumb is, in an exercise, the more people you have, the lower the classification of the exercise. And that means we have to obfuscate our capabilities and our tactics with the attendant risk of learning the wrong lessons. That's not a new problem, though. I remember checking in with F3 playmates during live exercises, only to be told that 1, 3, and 4 were dead and should go home. Oh, great. Now, we'd seen their radars looking at us, but we'd had no shot indications. And when we asked why, how, we were simply told it was classified and we couldn't be told the details over the radio. Fighter mates, eh? Now, I'm sure the fighters got some benefit from sorting and attacking the targets, but we got no opportunity to practice our defensive tactics. In the synthetic world, we rely on the white force to manage this tension, both through careful scenario design and through active management of the exercise. This ensures that running the exercise, the same scenario at different classifications, results in the same outcomes and the same lessons being learned. But it also means that crews may end up repeating the same exercise a number of times at different classifications. And we need to make sure that their tactics and their switch selections are the same at each time to avoid learning those negative lessons. As I said earlier on, simulation is only part of the answer, not the answer to everything. Turning to safety. I've always understood that every flying order book entry, every air staff order is there because somebody's had an accident. Operational activities such as air combat manoeuvring or weapons delivery are inherently risky, with politicians and commanders willing to take a lot more risk in wartime than they do in peacetime. And controlled airspace is a good example of risk management that will be familiar to us all. When I look at the low flying chart there, every patch of airspace is there for a reason. To enable all airspace users, yes, including freefall parachutists, to coexist safely. And that's absolutely appropriate in peacetime, where safety is our primary concern. But in wartime, that risk calculus changes. And many peacetime constraints disappear. So training in peacetime airspace doesn't really simulate how we will operate in wartime very well. And this is one area where simulators come into their own. They allow us to train in representative wartime airspace in a way that we can't in the real world. In a simulator, it doesn't matter if you overstress the aircraft, if you crash into the ground, or if your tactics don't work. You simply stop the sim, review and debrief the exercise, and go again. Now, you might be embarrassed, and you certainly will be if there's a QFI or a QI in the room, but you haven't killed yourself and you haven't thrown the aircraft away. You can analyse whether your tactics work or whether you simply got them wrong. When we combine these capabilities with the ability to link simulators together, to deliver exercises using qualified training staff, to rehearse and replay individual mission segments as many times as we need to ensure the right learning comes out, we start to unlock the full potential of simulation to complement our live flying and to improve our safety and operational effectiveness. I hope that my frontline colleagues, either serving or former, will agree how critical secure synthetic capabilities are to our ability to develop those battle-winning capabilities, techniques, tactics, and procedures. One of the arguments against synthetic training is that it doesn't provide the same feeling of immersion or jeopardy that live flying does. We don't get the squeaky bum moments that we all recognise from live flying. Now, I agree with the principle, but I think that improved graphics, appropriate use of movement, and new technologies such as extended reality are closing that immersion gap between live and synthetic flying. Importantly, problems with cyber sickness have been largely overcome and driven by the commercial gaming sector, which is an important factor. As an example, the Gladiator program has worked directly with Varjo on the development of their MR4 headset and its incorporation into a targeted fidelity training device. The headset enables the pilots to get a good an immersive out-the-window view, but also to read their high-fidelity cockpit displays and their knee pads. That gives them high levels of immersion without the need for a full simulator dome. Overall, of course, I agree that being in a sim is not the same as being in a live aircraft. The vibrations, the smells, the environments just aren't ever going to match up entirely. But I do think that if the physical and if the synthetic environments are good enough, then a sim can provide good levels of cognitive immersion and of training. Incidentally, those extended reality capabilities, combined with high-fidelity terrain imagery, are delivering one of the capabilities that Sir Jock talked about in the first Ed Link, by allowing commanders to remotely reconnoitre deploying remote locations before deploying. This means that they can understand the terrain and develop their force dispositions in advance, helping them to hit the ground running and reducing mental acclimatisation time. Now, it's not just the sexy stuff like flying, clearly. Defence uses modelling and simulation in many other areas too. Whether it's a simple logistics management database or a war game to help decide between potential courses of action, models and simulations are central to everything we do. What we aren't good at is creating the linkages that enable us to use data and insight from one application in another. This prevents us maximising the benefit of individual activities and means that we often waste time, effort, money relearning things that other parts of the organisation have already found out. The close architectural relationship between Gladiator and Eldon starts to address this. It brings a synergy that is already being exploited through development of operational capabilities and through validation of research outputs in operational use cases. The final example I want to look at is uncrewed aerial vehicles, or UAVs. Back to the Ukraine war, which has seen an increasing use of UAVs in a wide range of roles traditionally delivered by aircraft, long-range fires or special forces. And as well as the one-way short-range attack and spy drones used to great effect by both sides, the UK sees larger, more capable UAVs as an integral part of our future force mix. These autonomous collaborative vehicles will operate alongside crewed aircraft to maximise our overall capability. They will reduce operational risk in dull, dirty and dangerous roles and enable us to use crewed platforms in situations where we need a human decision maker. Deployment of advanced capabilities like UAVs is almost exclusively carried out in the digital world, both to preserve operational security, but also for safety reasons. Numerous incidents between UAVs and civil and military aircraft demonstrate the need for appropriate regulation, and they mean that the Air Force is unlikely to get the clearance to operate UAVs in the real world until we've demonstrated fully that we can operate them safely in a high-fidelity synthetic environment. Protector's accreditation for use in controlled airspace shows how this can be achieved and is an approach that we will likely reuse in the future. So, that's a recap of how we currently use simulation. Let's dust off the crystal ball to consider why and how we might use it in the future. As Link Taylor said to me when I arrived in AirCap, someday this will all be holodecks. Was he right? Deterring or defeating hostile military action requires potential adversaries to feel that they have more to lose from attacking us than they have to gain. And so we must possess capabilities that our allies value and our potential adversaries fear. And this can only be achieved through a whole of defence approach and as part of an integrated coalition force, with each service playing an important part. So let's start with what we know of the strategic concept and what this tells us about the future operating environment. I think it's safe to say that the era of Western technological dominance is at an end, and that our vision of a rules-based democratic world order is under significant threat from the rise in authoritarian and nationalism. State and non-state adversaries have all benefited from the proliferation of advanced technologies. And this enables both Russia and China to match the West's capabilities in many areas and exceed them in some. Equally importantly, the size of their armed forces enables them to negate any remaining technological edge through sheer weight of numbers. And we need to be able to counter this. In and leading up to any future conflict, opponents will attempt to prevent us monitoring or attacking their military infrastructure, while long-range sensors and hypersonic weapons will give them an increasing ability to hold ours at risk. Defending against the latter requires effective integrated air and missile defence. Achieving the former means our capabilities must be able to penetrate hostile airspace, gather intelligence and identify and strike targets, and do this despite degradation of our command and control networks and the space-based capabilities we take for granted. Just think how dependent we all are, our phones are, for space-based capabilities for things like communications, navigation, banking and commerce. In such a contested air environment, such a contested operating environment, only air platforms have the speed, reach and resilience needed, while the requirement to fight ethically, even if our opponents don't, makes it imperative for us to retain a human-in-the-loop decision-making capability or a human-on-the-loop decision-making capability, resulting in an enduring need for crewed platforms. And equally importantly, maintaining that operational effectiveness in the future will mean that the first time we use our full capabilities in conflict is the first time we use them in the real world. So we must maintain as much of the element of surprise as we can. As I said earlier on, the war in Ukraine shows that no part of the world escapes that constant surveillance. Therefore, we must be able to carry out our full and total force development process from initial concepting through to mission rehearsal in a secure environment away from prying eyes. And the digital world is what offers us solutions to many of these problems. Artificial intelligence and machine learning already far exceed our ability to process vast amounts of data, identify linkages and provide us with the insight to make sound evidence-based decisions. As a few examples to augment ones you've already seen today, Digital design and model-based systems engineering enable industry to develop complex products to high levels of maturity before cutting the first piece of metal or producing the first prototype. Digital twins enable F1 teams to monitor the performance of their cars and drivers and adjust race strategies to maximise their chances of winning. Amazon uses its machine learning algorithms to make sure that anything we purchase off the app can be delivered to our door in improbably short timescales. And then finally, extended reality goggles and high-fidelity imagery are enabling professionals in almost every profession and area you can think of, as well as gamers, clearly. And with that comes data. Everything we do in defence creates data that we can exploit, but simulation exponentially increases that data capture capability. We need to be able to mine this data for insight that allows us to accelerate our force development process and to optimise our capabilities and tactics. As we discussed earlier on, while we can do a test or a training event once or twice in the real world, using simulation, we can quickly, easily and cheaply repeat the same event hundreds or thousands of times. Using machine learning to identify common patterns and linkages and understand why the outcomes that occur do occur. Our ability is now simply limited by the amount of compute we have available. Now, within the Air Force, we are starting to use those enabling technologies, but we certainly don't employ them consistently across the air environment yet. Our challenge is therefore to combine these technological building blocks. I saw a Lego model earlier on the screen, and that was very good. And those existing areas of good practice into a single coherent ecosystem where every single activity across the force development, operational training spectrums is conducted in the most appropriate environment and where we can share authoritative models and data easily between each application. The good news is that many of these capabilities are already in place. Sensor fusion correlates the vast amounts of data gathered by aircraft sensors, helping commanders and aviators to make sound tactical decisions by filtering out noise and giving them the information that they need, when they need it, and in a format and manner they can understand, avoiding them being overloaded. Machine learning algorithms help analyse tactical situations and help us decide how best to deliver the commander's tactical intent. Coming up with a number of different options with various levels of risk and effectiveness. Capabilities like Gladiator safeguard sensitive classified data while connecting aircrew and simulators operating at different classifications together. While the Eldon synthetic environment at the Rapid Capabilities Office allows us to accelerate development of new capabilities by conducting individual work strands in parallel and by sharing relative data and outputs between them. This helps us identify the technologies and capabilities that offer operational benefit and that we can then develop and scale in collaboration with our industry colleagues. But we need to go further than this. We need a research and development ecosystem that links component-level physical modelling to campaign-level simulations, and to ensure that our outputs at each level are consistent. We need to take the results from our force testing activities and play them out in capabilities like Gladiator and Spartan, and then feed those results into the digital tools that we use to design and manage our support services. In simple terms, we need to connect those existing isolated areas of capability and good practice into a coherent modelling and simulation ecosystem that enables and supports every part of our work. We need to use artificial intelligence and machine learning to identify the linkages and opportunities, enabling us to maximise the benefit of individual activities and the effectiveness of the overall system. And defence cannot and should not do this on its own. We must be a more intelligent customer for our industry partners. We need to be able to articulate what we need and why, to work with them, with you, to articulate our requirements, to conduct collaborative capability development, and to have the ability to understand where industry solutions meet our requirements or where they don't. We must also work in partnership with other government departments, with allies and partners as a single system of systems, part of a defence metaverse, if you will. Not the most apt picture for a strategic defence review, but we'll all be aware that one is underway. It's intended to ensure that defence is correctly sized, structures and equipped to defend the homeland and to project power in support of UK foreign policy, and able to make effective and efficient use of the resource that the government provides us with. Decisions made in this SDR will determine our ability to deter or defeat adversaries for the next generation. And so we need to make sure that the evidence supporting our requests for new capabilities, for more aircraft, for more people, is solid. And only modelling and simulation can provide the right depth and quality of evidence to back up our requests and to enable us to make the right decisions. So, to conclude, let's look again at my assertion that we can only win the next conflict by using technology to deter or defeat our adversaries. Hopefully, before the first shot is fired. Before they make their first move, our adversaries will have spent months and possibly years preparing. They will have analysed our capabilities and tactics, developed ways to minimise our advantages, exploit our weaknesses, and overwhelm our ability to react effectively. They will have used cyber attacks to disrupt our systems and infrastructure and done everything they can to make theirs resilient to our attacks. They will also have attempted to shape the cognitive battle space, seeking to reduce our will and ability to fight and our ability to discern the truth amongst an overwhelming deluge of credible mis- and disinformation. Russia's actions before the Crimea and Ukraine invasion show how effective disinformation and deception can be, while the ongoing tempo of ransomware attacks shows how dependent our systems and infrastructure are on the free flow of data. So we must also be prepared. We must understand our opponent's aims, capabilities, strengths and weaknesses, and we must develop ways to defeat or preferably defer them. This must all be done without letting those potential opponents find out what our capabilities are, and as part of the integrated multi-domain coalition force we know we're going to operate as. And only simulation enables us to do this. Delivering this ecosystem is a Herculean task, but as with any journey, the most important step is the first one. And as we've seen, many of those building blocks are in place. Creation of my post is one of them. My job is to move AIR towards that end state, a capability ecosystem where each activity is completed in the most appropriate environment and where we can easily share assured data, models and insight between different use cases and areas. So as a final reflection, that may not be so far removed from what Ed Link achieved. He took existing technology from a number of areas to invent the first flight simulator and deliver a paradigm shift in flying training. I suspect that Link would have been quite impressed by the impact of his invention and the way we've developed it, but I don't think he'd be surprised by the fact that his inquisitive, inventive and practical approach is a model that is as relevant today as it was then. I hope my words have given you an idea of how civil and military use, specifically of simulation, have evolved since Ed Link's seminal invention, and why use of simulation is more critical now than ever in a world where the lines between the real and the digital are increasingly blurred, and how AIR plans to bring simulation and simulators into every part of its business, and to do that in partnership with military and industry allies and partners. Most importantly, I hope my words have prompted thought, and I look forward to your questions. Thank you.
Thank you very much indeed, Rory. Excellent presentation. Thoroughly enjoyed it. I learned stuff as well, which is even better. So Rory's kindly agreed to take some questions. People will move among you with a microphone. If you could raise your hand and just say a little bit about your background if you wish to, if we ask the question. But to start things off, I get a question. And my question is, Rory, if I could wave my magic wand and give you the budget for modelling and simulation you want, rather than no doubt the lower one you're actually allocated, what's the first thing you'd spend the money on tomorrow morning?
It's an interesting question, Chris. One of the interesting things is actually you don't need a big budget for modelling and simulation. Now, I'd like that digital twin-based modelling and simulation ecosystem, and if you can give me that for Christmas, that would be great. But we start off with the small things. I said, many of those building blocks are in place. We've got isolated pockets of good practice all over the place. My job is to build the bridges between them and enable us to share data, etc. So probably the first thing I would do is enterprise licensing. Within defence, we are mandated to use commercially available off-the-shelf software and to use stuff that defence is already using rather than bring in multiple versions of the same component. Now that's the stick that defence policy beats people with. If I compare that with the carrot, by making the software they need to use free, and I can deliver a saving to defence at the same time by negotiating preferable rates, then that starts to build that ecosystem and move people in the right direction.
Thank you, thank you. I think we have a question at the back from Ian.
Yes, I'm Ian Straw, and I ran the simulation office in the Ministry of Defence in the late 80s and early 90s, when a whole load of air marshals, and indeed admirals and so forth, wanted training to be done in the aircraft. But the two arguments actually that proved conclusively that we had to go for modern technology flight simulation. Simulation saves money, and it also saves aircraft. And I used to say to the air marshals, how do we actually simulate our war routes? How do we simulate the enemy? Oh, sorry, fly against the enemy. We can't. The only way you can do this was simulation. And that worked. And hopefully this trend has now continued, but there was a lot of opposition. Air marshals used to say, oh, you've got to fly the aeroplane. What about the crashes in training? You solve that by training those hazardous events in a simulation, which we do now.
I think that's very valid, Ian, thank you. The barriers nowadays, I don't think are the 3 and the 4 stars. I think they get it. I think they get the money point. We all get the money point nowadays. But I also think they get the operational effectiveness point. The barriers to progress are actually at my level. They're the people who are used to the initial 80s, 90s, 2000s flight simulators that weren't very good, that didn't have the visuals, that were just emergency trainers. When they start to see what can be done in the new Typhoon sim, in the Lightning sim in Gladiator, they start to understand what you can achieve. Now, as I said in my talk, I'm not saying that we do everything in the sim. The only way that you know that a real live air-to-air missile is going to come off a real aircraft, fly to a target and explode at the right time is to fire a real missile from a real aircraft. But that's at the culmination of a raft of modelling and simulation activities that have enabled you to test each component, each system, and then each system of systems. So when you do your live test, it's a confirmatory exercise rather than a voyage of discovery where things can go wrong.
A question in the middle.
Hi, Paul Jenkins from J2 Aircraft Dynamics. Has that gone off? Okay, there we go. So we do the flight test data matching. We build high fidelity models for air. Very interesting. You mentioned about data. You run the risk of swimming in data. I'm just interested in your thoughts here, because if I use an example, an offline analytical task in J2 is every 1,000th of a second. So for a 1-hour simulation, that's like 3.2 million pieces of data. And I just wonder if you've considered, when you look at the data side, the amount of data you need in order to make a value judgment.
I try not to think about it too deeply because it has me awake and screaming at nights, but you're exactly right. I talk about a modelling and simulation ecosystem. That can only work if it's built on a data ecosystem underneath it. Not only the authoritative data that we populate our models with, but also the data that we collect. And as I said, and you know, as you very, very eloquently articulated, we collect so much data from a simulation. We've got to be able to do something with it. We've got to be able to curate it. We've then got to be able to have the tools, whether they are machine learning or otherwise, to be able to mine it and to draw out the useful information from the noise. We've not got entirely to grips with that yet, I don't think. And there are lots of things that we need to do: metadata, how we store, where we store, the different classifications of data, what happens with aggregation of data, and all of those things. Those are things we have to grapple with, I admit.
Got another question on the other microphone at the back from Mark.
Hi Rory, great lecture, enjoyed it tremendously.
Thank you.
your latest sort of generation of digital natives or recruits into the armed forces now, do you find that they have a expectation that they expect a deeply immersive digital training environment now to support what they're going to be doing for real? Has that expectation changed tremendously over the last few years?
Absolutely. Let me give you two examples. So talking to Group Captain John Butcher, who's on board the carrier at the moment with the Lightning Force. He's effectively the commander of the Lightning Force. He was talking to me about two of his junior pilots who'd come through from flying training. One, an absolute natural aircraft handler, absolute fine. And the other one, not so good, but a gamer, a digital native. And he said the most effective Lightning operator is the digital gamer, the digital native, because he knows how to operate the Lightning systems effectively. They're just second nature to him. And an aircraft like Lightning, if you get into a situation where you're dependent on your flying skills in a dogfight, you've wasted that aircraft. It shouldn't be there. It should be taking targets out from well over the horizon before they know it's there. To give you another example of the Air Force's Astra initiative, where we take those digital natives, those young 20, 25-year-olds who are gamers in their spare time, who code, etc. And they're the people who are going into their workplace and going, hey, we could do this differently. And they're writing apps. They're writing extended reality headset scenarios that relate directly to their work. And this is one area where the hierarchical rank structure of the Air Force doesn't help us out. Because, I mean, I'm not anywhere near the top of the tree, but a corporal or an SAC is going to struggle to bring an idea to me, because he's just looking up that tree of life. And we all know what you see above you. So we have to put those structures in place to be able to do that. So we've got the Air Innovation Fund, we've got the Astra Initiative that build on those people, that give them the opportunities to develop their skills and the capabilities, and then we help them take them through the valley of death into an operational capability. Good question, thank you.
Got a question from, I think it's Torvald, isn't it, from Saab?
Yes, so I'm Torvald Mortensson from Saab, Swedish defense company. I was thinking here, at least one of the previous speakers talked about how the importance of sharing ideas and how we should collaborate. At the same time, as you have this illustration about Big Brother is watching, so do you have any thoughts on how should we collaborate when, I mean, there are European companies have offices in China, the European companies are now owned by China, etc. So how should we work together with universities, with other companies, etc.?
It's really difficult, isn't it?
Yeah, absolutely.
We would all love to think that we could do it on our own. If you think about the old enmity between Britain and France Germany, across Europe, we'd all much prefer not to rely on anybody else, but we can't. We have to. You know, the Air Force would never go to war on its own, because why? The Air Force exists to enable the Army to take and hold ground. Don't ever tell the Army I said that, please. Yes, you can. Yeah, you can leave. By the same token, the UK on its own is not going to deter or defeat anybody else, really. I think those days are long past. So we're only going to go to war as part of a coalition, and therefore we need to be able to train and operate as part of that coalition. Let's just look at Lightning. I think the numbers are, by the end of the middle of the next decade, there will be about 600 Lightnings in Europe. And the United States will own about 80 of them. And there are lots of little bits of patchwork airspace within Europe that are smaller than the Lightning sensor footprint. So we've got to work together. We're pushed into it, Thorvald. And there's always going to be that tension between your sovereign capabilities and what you're willing to share. Now, we see that with the Americans all the time. We suspect, we know that for everything they share with us, there's a special American, Make America Great Again version that is shinier and generally bigger than ours. We kind of have to accept that. But it's a constant balance that, thankfully, people well above my pay grade are paid to deal with.
Thanks. Thank you. I think that's probably about it for questions.